All right, so a quick note on that last problem. On that last problem, we started with this guy. And we said, okay, well, root 9 minus x squared. Let's see, 9 minus x squared most looks like this guy. A number minus something squared. We said, wait a minute, well, this doesn't look like 1 minus something squared, so we fixed that. These first 3 steps were all about fixing that. We said, okay, we'll factor out a 9, put it there. Square root of 9 would be 3, and then x squared over 9, we'll rewrite that as x over 3 squared. And then we said, aha, now we do have 1 minus something squared. All right, your book skips all that. Your book just jumps to the chase and says, okay, if you have that thing, just let x be 3 sine of theta. The reason is, if you do that, everything will work out great. Dx d theta equals 3 cosine theta. So dx is 3 cosine theta d theta. So your book says, all right, just jump straight to the chase, say let x equal 3 sine theta. If you do that, x squared will be 9 cosine squared theta. Or sorry, 9 sine squared theta. On the bottom, you'll have 9 minus, all right, x squared becomes 9 sine squared theta. Dx we're replacing with 3 cosine theta d theta. All right, so on top, 9 sine squared theta. On the bottom, now what you can do is say, oh yay, a 9 magically appeared. Great, we can factor out that 9. So we have 9 times 1 minus cosine, or 1 minus sine squared theta. Here we still got that 3 cosine theta d theta. Say, yay, now we have 9 times 1 minus sine squared on the bottom. Well, we'll say, okay, well, we can take that 1 minus sine squared, replace it with cosine squared. And we'll say, great, all right, square root of 9 cosine squared will be 3 times the absolute value of cosine theta. But as per usual, we will actually be able to get rid of those absolute value bars. Just ignore them. And we'll end up with finding the antiderivative of 9 sine squared theta d theta. So that's what your book would do. Well, I mean, at the end of the day, your book and I got to the same step anyway. I ended up here. Your book ended up here. It didn't really make a difference. It pretty much became the same problem. So your book just says, okay, if you got 9 minus x squared there, you're going to let x be 3 sine theta. The way you're getting that 3 is you're taking the square root of 9. And then down here, when you plug stuff in, x squared will become 9 sine squared, and you'll be able to factor out a 9. All right, so why don't I do that? Because my way seems longer, and it is. The reason why I do these problems this way, where I get rid of that 9 first and make this look like 1 minus something squared, is because this is a general trick that works in a whole lot of different situations. And so I like doing it this way for 2 reasons. 1, it cuts down on some of the memorization I need to do. And 2, this trick helps me out elsewhere. So you guys probably, I don't know, I would encourage you to do some of the problems this way to get some practice using this trick, making something look like something else by doing some sneaky factoring. Anyway, but there is reason behind my methods, so if you prefer to do it the book's way, that's fine, but I'm going to continue doing it this way because this trick will apply to other situations.